Okay, so we shall begin this session. So, good morning to one and all present here. Myself, Ms. Brinzel Rodriguez, on behalf of the management team of St. John College of Engineering and Management, our principal, Dr. G.V. Mulgund, and Department of Information Technology. I take this privilege to welcome you all for today's session on Introduction to Microservices. So I feel very privileged, okay, in a very special way. I feel honored to welcome our resource person for today, that is Mr. Tanmay Colaco. He is, as you can see on the screen, his credentials. He's a senior software engineer at Cimpress India Private, but also it is an honor to say that he is our alumni from the 2015-16 batch passed out. We, in a very special way, we welcome you, Tanmay, for today's session. And I request our HOD, Mrs. Anita Chaudhary, to address the students and welcome our speaker.
Okay, thank you, Brinzel. So Tanmay is basically the introducing the microservices. I'm not an expert person in microservices, but still I took the day off, so I can say about the microservices. Definitely, it plays the important role in the industry as you are implementing the softwares, applications. Okay, so whenever I built up the application, the large applications you people are developing, the application development is the important part. After that, testing, deployment, these are the very important stages into the this product development or the application. Okay, so basically the thing is that if you are deploying the large application, that the small modules are there. If the small change is happening into the one single module, everything again you have to think, again you have to test, again you have to deploy each and everything. Okay, so it takes the time for the development team, testing teams, even the deployment teams. So to bridge the gap between these services, the microservices concept comes into the pictures. Like if you are means like observing the Amazon, so the payment is a one service, whereas when you're putting the items into the cart, that is another module. It is considered as another service. So these are the different services, and you're working together. That's why. If the small change come, only the payments module will be considered, and the change will happen into that payment module, and then it will test it, and then it will deploy it instead of the whole applications. Okay, so I hope whatever I'm talking, is it right, Tanmay?
Yeah, ma'am, you're right.
Okay. Thank you. Okay, so this is all about the microservices. So definitely this is a very good concept that today Tanmay is covering. And it definitely will comes to know, as you are the software engineers, the IT peoples, you're going to develop the applications when you join the industries or when you're working on your project. So this concept definitely matters a lot in your syllabuses and curriculum also. But it is not definitely, it is not in our syllabus. DevOps is there, but microservices, they are not included. Okay, but you should know these things. So Brinzel ma'am has organized such a seminars for you for getting the knowledge. And I just welcome to Tanmay. He's an alumni of 2015 and 16. I just remember Tanmay was in second year, KT, but very much brilliant person. Huh? It is not like the KT and he can't do anything, but he is really a brilliant. उसको हमेशा syllabus का doubts नहीं आता था. Out of syllabus doubt, he always going to ask to teachers, any teachers. I taught them so many doubts. 2-3 people of the group with the Tanmay, included Tanmay. Okay, so and a company came to the college, newer company, and that I think around 100 students has applied for that company. Single students they are selected, and that was Tanmay, because each and everything critically he only able to do. The time complexity of each program, then how the program will be efficient, even though you are writing bubble sort, pick sort, merge sort, but how this program is efficient to run in terms of run time complexity and in terms of the space complexity, that Tanmay is really concentrating on these matters. Okay, and that is really wants key instead of like the theoretical thinking, theoretical marks and all this. this matters, but alternative knowledge also matters a lot. And that time, out of this 100, only Tanmay has selected. We are really a proud moment for us at JCEM. Okay, so the thing is that that is all about my alumni. He is a very good person. Even though 15 16 pass out batch, he in the touch with the faculty. Every time they are contributing to the departments. I thanks to the Tanmay for accepting our invitations in the small time span and taking the session. I welcome you, Tanmay, for the taking the session on introductions to microservices. Thank you.
Yeah.
Thank you, ma'am. Over to you, Tanmay. Without much ado, we can start this session.
Yeah. Thank you. Let me. Share. So, good morning to everyone. First, I will start with sorry because I'm taking up your Saturday. I know it's a holiday for the students. So, I would like to thank Anita ma'am and Brinjal ma'am for a very great introduction. I'm not that nice, but thank you. It feels good to be back to the St. John. This time not on a bench, but giving a presenting to my fellow like students like who are going to be soon alumni of the college. So welcome. As Anita ma'am gave a very good introduction, this is going to be an introduction to microservices. The whole aim of this is for you to know what is a microservice. So when you come to an industry, many people, even the interviewers, try to scare you saying, "Oh, we do microservices. Are you ready to do microservices? We do this, we do that." It will provide you more of an understanding. Okay, what is a microservice? Then I write a microservice right now. If I tell, okay, you can write this microservice. Will you be able to write a microservice? It will give you an introduction. It's more. The session was actually planned before this whole corona pandemic situation hit. So I was going to give you some more practical things to do, but now we are limited to theory, but I will try to make this session as interactive as possible. So hopefully you don't sleep. So yeah. So Anita ma'am gave an introduction about me. Still, I would like to give a small introduction about me. I'm a senior software developer at Cimpress India Private Limited. Most of you may not have heard of this company. They might have heard about one of their companies, that is vistaprint.com, if you order some customized cards or all. So that is there. I have around 4 years of experience totally working on the industry from 2016. As I passed, I started working until now. I have worked with clients like Standard Chartered Bank, Deloitte, and Piramal. I've been working with them, consulting on them. I love to code, so I started coding from a very early time. So I'm very passionate about it. I like to code. That's why I joined IT. I also manage a YouTube channel. So do subscribe. I will send you the link afterwards. So okay. So let's start. So one point, you can interrupt me anytime to ask. There is a dedicated time I have allotted it for the Q&A session, but feel free to interrupt me and ask, because there might be some terms that the fourth year or the third year students might know, but the second year students might not have heard about or get confused. Please feel free to interrupt and ask. Even for the teaching faculty, please feel if you think that one term the students may not understand, and I would be happy to explain it.
Tanmay, I would like to just say one thing. Students, if you have any doubt, as Tanmay said, your doubt you can put in the chat section.
So I'm writing that application in this architectural pattern until I progressed around 1 or 2 years into my career. I was not aware. I was just writing an application. Throughout the college, generally we write monolithic applications until someone is passionate, learns about this thing. The syllabus is structured because monolithic applications, as you will see forward, has some advantages to it. So what is a monolithic application? So in layman terms, it is just a big container of lot of code. All of the components that you write, all of your code is just in one place for you to there. You can edit it, you can write. It is very tightly packaged. Like you are using different code pieces from this class, from that class, from this package, from that package. So it is very tightly coupled. In the industry, we don't say this it's a big container and all. We just call it a monolithic architecture. So how we generally write code, or when we get out of college, it is about monolithic architecture. But there are problems with the monolithic architecture, that it is inflexible. Like you cannot write, if you keep writing more, it gets very huge. So it takes time for deployment. It takes time for testing. There is many people involved. For example, if I am writing something and you are writing something in the same piece of code, it may happen that I can comes, it's not more reliable. Your code is deleted. Your all effort will be wasted. It's not flexible. But what will happen is, if I'm writing a piece of code and if someone else from my team is writing piece of code, it may happen that we have not tested our code together. When we go to production with both the codes, our individual codes were working fine. But when we merge it, it might throw an error. It might stop something. So this is very critical, the rely on Google. If you know that Google recently had an outrage, that 1 hour Google was down. The reason for that being down was one of their service, very important auth service, was down. So they were very, but they would have not known where the issue is, who committed it, or who made that bad code commit. Second part comes up to it that it's unscalable. Like if Google was a if Google was a monolith and a big application, how much did it scale? Can I handle 10 users? Can I handle 10,000 users? The cost would go up. There might be some piece of code that is never being used, that is only used once a day. But I have to spend cost on deploying that application and running it so that 10,000 users can access that piece of code. But in a day, only 10 users access that piece of code. So why should I pay for that piece of code together? Because it's a monolithic, tightly packed. I cannot just put 2 pieces of code up for 5,000 users to handle and 1 piece of code to just say, okay, you can handle 10 pieces. So that is a very big disadvantage from a company standpoint, from a cost standpoint. When you're going, each and every dollar that you're hosting matters. Then this comes up as blocks continuous deployment. So I think many of you must not be knowing. Anita ma'am did mention that you have DevOps subject. So what is in continuous deployment? Continuous deployment is something that, okay, your code is ready, you test your code, you deploy it to production. There is no fixed deadline. You're continuously deploying your production, your new features to the production. But with a monolithic architecture, it is very hard to do that because you have to wait for each and everyone to complete. So if there are 3 developers on your team, you have to wait until all the 3 of them have completed their work. You test everything and then you deploy. So when 2 features could have been released, because the third feature is going to take 2 weeks extra, it is delayed due to any n number of reasons. Now your features are also delayed. The client is getting affected because he at least should have got 2 features. He could have waited for 1. Now he has to wait for 3. So that is another issue. The second part comes up, like next is somewhat related. The development is very slow in this type of architectures because what is happening? Each and everyone should be in the development industry because you have to have the above things moving forward. All big companies are doing it. So this is a basic problem with the monolithic architecture when you come in terms of what we are learning, how we are learning to develop an application into college, and how we have to move forward. And this is most of the time when you joined as a fresher, you might get this monolithic architecture for legacy applications. When you're starting your career, many less companies offer direct on production, on good quality projects. They first start you with little old projects. So even if you mess up, it's fine. So you will face monolithic architecture. It is not denying that you will never see a monolithic architecture. It is out of the industry. You will face monolithic architecture. You will face the challenges, but you know what things now you need to take care of. What is a monolithic architecture? Any questions related to this? Please feel free to ask. Okay, so I will continue. I think that is clear. So to this comes up what is a microservice? To solve many of these problems, what is a microservice? Now, this is a textbook definition of a microservice. I can read it for you. Microservice is an architecture, right, that structures an application as a collection of small autonomous service model around a business domain. So it is a very, very business bookie type of definition. No need to think about. Yeah, you wanted to say something? Okay. So this is a very booky definition. You don't require to memorize it. Just understand microservices are just small applications that are interconnected using something. Mostly it is in your internet. So I just break down my monolith into 2 or 3 different services, and they are all connected with an internet connection, with an HTTP call, with network calls, where I can communicate. So microservice 1 is talking to microservice 3 is talking to microservice 4. This way, everything works in a business domain. Business domain is just your project for this thing. You can just consider it as a project. So take an example of an e-commerce site. My whole e-commerce website, consider Amazon, is a whole business domain. Now I can have microservices around Amazon. If I clarify, if I go into further, the home page that you see can also be a business domain. The products you can see can also be a business domain. Now inside that business domain, also I can have many microservices. Amazon has hundreds and thousands of microservices, thousands of people working on these small services, and we only see one application, that is the Amazon.com. So like when you click checkout, there are over 50 services that are being called in the backend to just place your order. We are not aware about it. It works so fast. But this is the flexibility that microservices offer. So this is the textbook definition if anyone wants to know. More of a practical definition, it's just an container of different small services which interact with each other using some kind of mechanism. Preferable mechanism over here is in the internet. A lot of network calls, HTTP requests. If you're aware about GET, PUT, POST, that is used widely, that is REST requests. So this is an example of what we call a monolith application, and this is a microservice application. So this is what my monolith looks like. I have an UI, I have the business logic, I have the database, I have the server, and this is what my user will access. It faces all the complications that I have said earlier. Like there are a lot of problems with it because I have a lot of logic over here. See, the UI is here, the business logic is here, the actual code, the database calls are here. It faces an issue. When I shift the same application in the microservice way of doing things, I see this is the UI, and I see there are different microservices connected to different databases. Now, what happens is it provides me with a set of advantages that whenever one of the microservice is going to have load or needs more resources, I can just scale that particular microservice. I can just scale that microservice. I can provide that microservice resource. The cost is very less than scaling the whole application, which doesn't require to be scaled or doesn't require to handle the number of user load. What I mean by scaling is just increasing the number of applications or increasing the CPU size. Like for example, this all run on computer and virtual machine. So if my virtual machine has 1 GB RAM and 2 gigahertz processor, I shift it to 4 GB RAM and 5 gigahertz processor. That is what I mean scale. Or I create 2 machines with 1 gigahertz or 2 GB RAM, 2 GB RAM. So it is 4 GB RAM. So this is all what I mean by scaling. So I'm not buying the machine because here I can only buy one machine with 2 GB RAM. It's fine. But here I need to scale it again to one machine with 16 GB RAM. Do I need that? No, I don't need it. But because of the limitations with monolithic architecture, I will have to do that. So this is how a microservice architecture looks compared to a monolithic architecture. So what I will do is I will try to interact with you people. So let's create a monolithic application. Let's see how a monolithic application for an actual Amazon or an e-commerce site is structured with. What all different components there are. Maintenance going on. So the tool is down. Really sorry about it. So if I want to develop an e-commerce application, what all things I require? What all things will I require? Let's ask you. Come on, suggest me something. What will I require? Any one of you can suggest what do you think an e-commerce application has in terms of code? UI, okay, right? I have an UI. Then payment options. Okay, so I have payments. Okay, I have a database, right? Anything else? What do you require? I have the actual products that I need to sell. So there is one code that will get me the products I need to sell. Yeah. Server. Yeah. Okay. This whole thing is a server. So this is the server. This box is the server. Yeah, client is something that is external, so it is not part of our code. If you mean by client that actual the persons that are buying, so it is an external thing. So we have client, but it is more of outside. Okay, then we have cart where we can add things. Then we have a way of letting, yeah, product tracking. So we have logistics, what we call in our terms, it is product tracking. This is product tracking. So then we have cart, products, product tracking. Okay, let's go with this customer service. Okay, yeah, customer service works. Done. Thank you all. That was really helpful. I also forgot a few things. So this is your whole application. Now, with me being an entrepreneur or I'm just starting out of college, this is what I designed because I'm not aware about what is in concept of microservices. This is what I designed. All of this may be in Java terms, if you're aware, this may be classes. This is just piece of code that is there. This is not services. And there's one database that I am interacting with over here that is taking all the load for these services. So this is what we call as a monolithic architecture, where everything, all of the services now come to a very real life example. Whenever you go to Amazon, do you add anything to the cart? No, you don't. So does this require to be scaled? Will there be thousands of users using this service? No, right? Does with any of your product, do you always have problems? Are you always reaching out to the customer care? No, right? So there are not thousands of people reaching this service. UI, yes, everyone that comes to Amazon is going to use, or e-commerce site is going to use the UI. So if this service particularly has load. Payments you are always going to make payments, but are you always going to buy? So this will have load, but not much as the UI or the product services where every time you go, I need to see what. One more thing I think we can add to this is search. This is an important aspect of Amazon where I can search products. So search will also have a heavy load. But as everything of your service is in a monolith, you have to scale this whole block. You cannot just scale only what I require. So wherein I am spending $1,000 a month, now I need to spend $10,000 of the month because people are just coming to my site and not buying anything. I'm just going into a loss. This is one of the complications. The second complication with this kind of an architecture that we have just built is if my customer service goes down, if there is some problem with my customer service, that means everything is down. People cannot come to my site, they cannot see my products, they cannot order. But this should not be have been the case. Only people that are trying to reach the customer service should have been affected. But because it's a monolithic application, everything is now affected, because some, like, this whole server is down because there is some bug in the customer service code. Everything is down. Now, what we will do is, let's separate it into an microservice architecture. Let's say that, okay, this is my UI. We're just going to go to this is product, this is cart, this is payments, there is a database, service, search, there is customer service. So, now if you see, I have split, and this is known as microservices. Suddenly the monolith has become microservices. These are all small Java applications or a Node.js application, different applications running, which are developed by different teams, very small teams. Now, if I'm not sure how many of you have seen, but there is a quote by Jeff Bezos that if you cannot share 2 large pizzas between your team, like your team needs and 3 large pizzas, then your team is too big. Break it down. So your team size only should be until you accommodate 2 pizzas, because that is how they operate. That is how all of the big companies operate. They don't want to keep it that, oh, person A needs to be always there for my application to be working because something he wrote is required in my application. They don't want that dependency. They want, okay, team A is going to make this, team B is going to make this. They should not be interdependent. Everything should happen through the internet, the community. Even in Amazon and Google, everything internal to them is communicated through not the internet, but through LANs and through the network, not through actual code. So this is the service. Now, as I was saying, the product service, I can scale it up. I can just have 2 product service instances, like 2 systems that are running the product service. The cart service, okay, I can have only 1. The payment is also, I can have 2. Payment I can just keep in case no one wants to it. Product tracking is also 1 because not everyone is tracking their product, right? If I'm only curious, I'm coming and all. The search I can have 3 instances because there are a lot of people that are searching for my product. So I can have search. Customer service also I can have 1 service. So now you see how it is way different than having the whole block replicated and other than having just this services. Now I'm only saying, or I'm putting an effort to scale the product services, the payment and the searches. And I can do it in a way that, okay, I can have search more. If there is a sale and people are searching more, I can just go ahead and add another search service. I can just go ahead and add another product service without ever impacting other of services or increasing my cost, increasing my effort in the other services which are not being used that much. Right? So this is the advantages, core advantage why everyone is moving towards microservices, why big companies, why complex applications are moving towards microservices. Any doubts related to this? You can ping me on the chat. I would be happy to answer. Okay. So this is how we deploy microservices. So one more thing I just forgot to mention is that error handling. So what if this service goes down? If this is down, it is in the red now. It is not working. It is fine. My products, my people can still go and search. My people can still go to the cart, still add, still do something. This is irrelevant. People will be complaining about this. This is an interruption, but I am not stopping my business. It is not happening that, okay, I cannot go to the site and order anything because customer service is down. See, this is not that crucial service. Also, when developing, I may not put lot of people into this customer service because it is not being used. My main focus is to optimize this both services because they are in. So the best, not the best, but a lot of people, lot of resources are put into this specific services. Like there may be 10 different teams working on search, 5 different on product, but 2 only on 2 products on customer service. Another advantage on an industry level that comes up is that when customer service is down, I know the team developing the customer service has to come and take it up. No one else is going to take a look. Why will the search team come to know? So I have a defined scope of responsibility that, okay, if customer service is down, I can I can come and the people who are making the customer service can come, take it up, check what the error is, get it back up. They will take the Google was down. The initial analysis said that the auth service were affected. So anything that requires your Google login was down. Google works on a microservice architecture. So there was an auth service over here that was in red. We can just call it auth over here. There was an auth service that was in red. People who were doing auth services came up and were able to fix it. This service had a lot of login responsibility. That's why all of the microservices were affected. That happens because the people working in auth services came up and were able to fix it. This service had a lot of login responsibility. That's why all of the microservices were affected. That happens because the people working in auth services came up. There is some dependence. Here they were quickly able to fix it because the people working in auth came to know, okay, my service has got affected. Let me fix it. So they were able to fix it. Mail goes down because there is some mail service. About this before now, like the advantages of microservice. Let's go one by one about what it is like. Improved fault isolation. So what I meant by fault isolation is again what I said with OAuth, like or what I said with customer service. That what I said with customer service. That once I have this block separated out, I can go ahead and fix the customer service. If the customer service is down, everything else is not impacted. Another important concept that we can look into is eliminate vendor or technology lock-in. So how it has happened in these big tech companies, what we see Facebook, Amazon, Google, or even at Cimpress, we are not bound by any language. So you are not a Java developer or you are not a .NET developer. You can be comfortable in whatever you're doing and write it in that way. No one is going to come and say, oh, why have you written in .NET? Why have you written in Java? No, it is not in lock-in over there. Microservice communicate through the internet. So I can have one microservice running in Node.js, Java. I can have one microservice running in C#. I can have one in Python. I can one have in Ruby, and everything can communicate over the internet. They don't need to, everything is a black box for them. What the code inside is. So the advantage is if my team is very comfortable in .NET, I can go ahead and write in service in .NET. If I feel going forward that okay, Java is not good for me, .NET is good, I can easily switch some teams to .NET while others are starting to migrate. With a very monolithic architecture, it is not possible to switch half of the code to some other language, half of this. So you cannot have half of code in Java, half of code in .NET. It is also known that some kind of projects require some kind of language. Like for example, you recently had a data learning workshop. So data mining and all are very optimized in Python. So you want to have your data mining applications in Python. But Python is not that good when you come to a very normal use case of enterprise coding and all. Python is not meant for that. So we can do it, but it is not used industry-wide. So this is what happens in microservice. We have the liberty of keeping it open to having. Then comes the part of ease of understanding. As I mentioned in the disadvantage of monolith, that everyone should know 20,000 lines of code to make any change. Now with microservices, everything is limited to just 1,000 lines, 2,000 lines, 3 files, 4 files of code, which you can easily learn, which you can easily understand. Even if you make mistake, the other person, the senior that you're working with, knows what you made and can correct you because they are aware about it. It's a very small application that you require. And the other part is that you know when something goes down, it is very easy to find, okay, if you made this mistake, that's why it's going down, you need to take care of this. With a monolithic application, that's not possible. Other thing is microservices have very smaller and fast deployment. Like I say, if I'm working on 3 features, the whole team is working on 3 features. I have 2 features ready, one is lagging. I can easily deploy my 2 features with one microservice and wait for the third feature to become. The client is also happy in this case because I have 2 features that have already been deployed, right? So he's happy that, okay, 1 feature is deployed. In the other case, I have 3 features that I require and none of them are there, but the 2 are required, done. But still because of the third feature, they are delayed. So this has very smaller deployment. So when you come to DevOps, deployment is just like deployment of a monolith is very hard because they need 100 of things to do. I may need to execute 10 scripts. I may need to execute 10 database updates. I may need to clear the old environment, do something, a lot of time. But with a small microservices, mostly they use Docker. I'm not sure if you are aware about Docker, but it's just a small container which I can use to deploy. We can explore it later. So that is very fast to do in microservice architecture. So these are some advantages. Again, the point comes up to scalability. This is same what I explained with your diagram. If my search and my product services has load, I can increase my search and product services. I don't require to increase my customer service or my cart service, which people rarely use. Or even if I don't need to put on more people to develop that service or enhance it because it's a very small service, but very less amount of people are using. So I can put in more effort where I can make more profit. Now, if my bill was going to be $10,000 for the month because I need to scale all the useless services, now I can only have $2,000 or $3,000 because I need to scale only 2 services. Why am I spending an effort on additionally scaling, developing, and maintaining other services? So these are the core advantages of microservices. So the question comes, so is monolithic architecture inherently bad? Why are people still using it? Is it evil? No, it is not evil. It is a good architecture, but it is limited by its potential and when it was designed. When the monolithic architecture was designed, it was okay. There were not many codings that was happening. There were not many complex applications. There were the applications were itself and Microservices were like, okay, 2 or 3 jobs because everything was manual. Now with the evolving time, the industry has to evolve, but still the monolithic architecture is very much prominent and very much in use because it's not bad architecture, but it is on you of how you are using it. If you use it for a very complex app, it's a bad architecture. But if you're using it with all the constraints in mind, then it is not a bad architecture. So the advantage is that if you have a small team, like you are working on your college project, do you want to have microservice? No, you don't have the time to make a microservice. You have a very small team. You have 3 people working. How are you going to understand microservices, write 3 applications, deploy 3 applications, then show it? And it happens. No one is, even if the facility is not expecting you to write it, it's fine. You can use a monolithic architecture in your college project, even in a company. If you're building an MVP is mostly the prototype of a project, the first version of the project where you can just say, okay, this is my idea, this is the application, the idea works, the application works. Now I will, once the company directors and everyone are happy, then I can go ahead and start making microservices. Again, did not get millions in investing, so this is more of that with different architectures, you need lot of small teams. So small teams cost money to the company, right? It may provide the above advantages, but they require team. They require that small deployment processes. They require a sustained effort, wherein the monolith, I can just deploy it like that. Just deploy it with, if it's a very small application, it's a very small application and I split it into 2, still it's an issue. It is better off being a monolith and single deployments and all. If you have experience in deploying monolith with some framework like Laravel, Ruby on Rails, where you know that, okay, this monolith application is going to work fine, it is fine. There is not that much services involved, it is fine. If you don't see the performance bottleneck, again, it's drilled down to what you have to analyze. When monolith is good, then microservice is good. There is no inherently good and evil architectures or an outdated and new architectural concepts. So people might come up and your friends, when you're working industry, might come up and say that, okay, I'm working on a microservice architecture. It is very awesome. No, it's maybe just, it is not that cool. It is nice, but monolith is also good. It is not bad. the requirement that you are working on is more suitable maybe for a monolith. That's why your company is working on a monolith. So that doesn't make your friend a good developer than you, or a good in tech company because they are doing microservices, you're doing monolith. That is not the case. And this is the last point is just one, that if you don't think microservices are good and you think I can handle very much complex monolith architecture, go with it. It's your own wish. It's your own company, own technical decisions that you have to go with. So these are all some sort of advantages of having a monolith architecture. So monolith architecture is very good in certain terms, but you're the person who needs to decide when I need to go monolithic. There are basic guidance factors that you will find throughout your career that, oh, this should be a monolith, this should be a microservice, but with experience you will come to know, oh, is this and mine should have been a monolith or should have been a microservice. So next point we come up to is, any questions regarding this? I'm been speaking for some time. So any questions regarding this? Just like why I need a monolith? Should I be using a monolith? Like any questions you can do, put it on the chat. I will be happy to answer. Okay, so no questions. So we can proceed further to the next part over here. Says, so how to design a microservice. Now with what I have been saying that it is up to your personal decision, these are the few guidelines. These are not extensive. There are many more concepts that you need to drill down into to design and microservice, which you can read or you will come to know as you move forward in your progress in your career. When I started, I was not aware about the term microservices or what. I have one question. Let me. So cloud architecture, these are same names for different things, right? Microservices are deployed on cloud. By cloud architecture, there is nothing else as cloud architecture or this. You are using your cloud. Even monoliths can be deployed to cloud. It is not the case that monoliths are not deployed to cloud. There is cloud architecture is just similar names to microservices what I feel. If you're using the cloud for your applications, it is cloud architecture. So microservice cloud architecture similar in a way that, okay, your cloud architecture is different. Cloud services that you're using for your application is cloud architecture. Different services you're creating to break down your application is microservice. Microservices and monoliths both can use cloud architecture. They can use different kind of cloud services that are there in AWS, Google, Azure. They all can use it. Hope that answers your question. Did it answer your question? You can just say yes or no. Oh, good. It was a nice question. Do keep posting questions like this. I would be very happy to answer, and it will help your fellow students to also understand maybe if they are hesitant to asking this kind of questions. It's a good question. Okay, so now we will continue with how do you design a microservice. So again, this is not an exclusive list. This is more of a guidelines for you to get started with. So mind the business objective. So why are you making a microservice? What is your business objective? Can this business objective be fulfilled by and monolith or no? Just go think about it. Like for example, Amazon. Amazon is a very, or even the payment space in Amazon. It can have 10 different services. It can include calculating tax. It can getting the product price, getting discounts and all. So the payment domain is also structured in a way that I can have different microservices. How many microservices should I have? It may happen that some people sometimes go ahead and overcomplicate the things. They are not, when you should have only 2 microservices, they keep 10 microservices. So having microservices too small is also an issue. So you have to structure your microservices very well, so that you need to know what you are building and why you are building. So when I say, okay, build a service for payments, design the whole architecture for payments. What does payments include? These are the few questions you need to ask. So this is more often when you progress further in your company and career, always ask questions until you're clarified. Ask questions. There are starting stages where they just think you open pressure and they will just tell you that, okay, just do it. And then you will be confused and you will always lag behind because you are confused. Until you get clarity, ask questions. So that is what my business objective it implies for everything you're developing, but specifically in microservices, you should understand what you are making to create and microservice. Like for payments, you have taxes, you have actual price, you have discount coupons, you might have 10 more components. But if you don't know that you also need to support discounts, you will not think about as a discount. You are not like making the discount microservice. Make sure everyone understands the task. It's more of like, okay, you know, when you're working as a team, you should know that, okay, I am working on discount, this other guy is working on payment. So everyone should know what they have to do. Other point is choosing the programming language. So this relates to an earlier point that I make, that some languages are good in some things and some languages are good in not doing that thing. Like for example, if like how Amazon or some other sites like Myntra and all keep you suggesting products. So there is an AI engine, a neural net that operates in the backend that scans your data and understands, okay, this person looked at cargo pants, t-shirts and suits, so he may be interested in the color red. So I will find a pant that is color red or a dress that is color red and I will suggest him. So that kind of a microservice can be written in Python. There is no requirement of or need of writing that kind of microservice in Java because that is not going to perform that well. Then the main point where you're actually going to get the price, if it's more like calling 10 microservices, it's better off writing in Node because it's quite simple to write it. It's quite fast. Then if I want to actually have a very heavy processing of calculations and all, it might be good to write it in Java or C#, an object-oriented language, other than Python or Node.js, which are not suitable for that work. They have some other purposes. So choosing your programming languages is very, very important. This is one of the most important points. I will like to give an example of my personal experience. I met a team. They initially had a lot of computation, AI kind of work. What the mistake they made is that they didn't think about this. They're very new of young developers, just hired freshers with some few experienced people. They didn't make an understanding of what they need to do. They missed the first and the second point. And then what happened is because they were not aware about the first and second point, they mistaked in the third point. They choose Node.js for their deployment. When they choose Node.js for very heavy computing work, if you are aware, JavaScript is single threaded. It cannot use your multi-core and different things that the OS provides you. So their computation and maths problems, maths core was always lagging. They didn't have the power to do that, right? They should have never went with Node.js. What they did is, other than, okay, now I am a microservice, so let's try to do something. They tried fixing it, but never. At the end, they had to move to Go language, which was more suitable for that work. So if you don't understand the first, second point, you're bound to make the mistake in the third point. And if you make the mistake in third point, then it is going to cost you time. They wasted 3 months to just create the first microservice, get to know that the first microservice is not working as expected, optimize the first microservice, and then again dropping the microservice and rewriting it again. But then here the advantage comes because they had a microservice with very less piece of code. They were able to rewrite it in Go in months' time. This was not possible with a monolithic architecture. Second part comes up with consider data storing. So how are you going to store your data? Are you just going to store your data in a file? Are you going to store your database in a database? Are you just going to dump it into Google Drive? How are you going to store? And consider data storage. So how are you going to store your data? Because different kind of applications require different kind of database mechanisms. Facebook still runs on a database, while Google and all are shifted to NoSQL, where everything is in key value pair. Some microservices might require the relationship database, some might not. So again, you need to think of how your database is going to be. What are my requirements? And then I need to, again, if you will not write an optimized service if you use a NoSQL database where you should have used a relational database. This is all things you will learn as you move forward in your career. But always when you're keeping in mind, having a discussion with your teammates about this, always think about this point. The last point comes up more, it will apply again in the future of your career, but you need to monitor your microservices. I personally check 10 times a day the service I write. to see how it is performing. Do we need to do some optimization? If I put something to code, because it's a very crucial microservice, my company could lose thousands and millions of dollars if that service goes down. So we need to have very strict monitoring of this microservices. It will not happen that someone else from other team is monitoring your microservice. You are responsible, you will be held responsible. So you should have a way of monitoring this. There are very, very different tools you could design, or there are out there that continuously you're looking into the services. Also, monitoring your microservices. There are some other points that we can consider, but they are currently not relevant to the stage you are at, so I have not included it. But this is the point that will help you if you reach a company, if you are in a company where you from the get-go, you get to work on microservices, you are asked to design a microservices, then these are the points you should always keep in that will give you an added advantage while thinking and while designing. Any questions related to this? Like, do you want any more clarification on any of these points? Okay. No questions, so I will move forward. So who is using microservices? As Anita ma'am in the start mentioned, every big company is using microservices because they know that their complex applications cannot be run on a monolith. So every big company, these are the few primary companies that run these are Netflix, Uber, Amazon, Spotify. Everyone runs microservices. These are few examples that are there. So even if for some services like Netflix and Amazon, if you get a job over there, you are surely going to get in working. They have nothing monolith left. They have killed all their monoliths. So you're surely to be working in that kind of an service where you will start working on a microservice. So this is some use cases. Two use cases I will cover of why. So Netflix is one of the best implement of examples. Netflix was one of the first very start companies to know that, oh, this monolith thing is not going to work. I need some kind of help. They designed their own microservice architecture. Microservice architecture was very in an early stage. So Netflix has a very huge contribution. They have made many open source contributions to the term of the whole concept of microservices. But Netflix is one of the great examples. If you can read, this is more of a read kind of an example, but I will surely explain it. What was happening is Netflix, there were many users that were streaming certain kind of content, but there were not many users who are always logging, because once you're logged in Netflix, you don't log in again. You don't, your payment is only processed one time a month. So Netflix was having issue with scaling this. It was happening that some content in India was viewed more and some content in America was viewed more. So they didn't know how to handle this. So that's why they designed an open source like microservice architecture the Netflix engineer created, which was able to handle the Netflix that we as know today. That can get us different kind of suggestions, that can get us different kind of images, that can handle different kind of things. Even if one aspect of the thing is down, it will not. So Netflix was the initial company to do it. They have made a lot of contributions to it. So Netflix is one of the prime examples. If you just Google Netflix microservices, you will get a very good stories about how their data engineers did it. Second is our all famous Amazon. Amazon started microservices same time around. They were also facing the same issues that how do we scale up, what things happen and all. Jeff Bezos at a point, it is known that he said that every communication should happen over the internet. There should not be big services, because we know that having big services was going to cause them a lot of server time, a lot of bills, not able to handle it, bad customer experiences. For companies like Amazon and Netflix, customer experience is the most important thing. If your customer is coming to Amazon, he doesn't get what he wants, he is not going to come back. That is a loss for the company. They always want. So when you join such companies, you can ask 2 days extra for a task to be done, but the customer should not be impacted. So this is how Amazon uses microservices. That when they designed their Amazon, the main web page, and they started using their own AWS, they were getting a lot of bills because they didn't know what to scale, how to scale. There were a lot of outrages because someone used to put something bad code in the main Amazon code and everything used to go down. So they decided that no, it is time. We need to switch out to microservices where everything as we designed earlier becomes a microservice. I interact with it. If anything, one service goes down, others are not impacted. The bills came down, and this is how they went into profit. This is how the whole AWS is designed, that you can just see lot of things there. These are all individual services. Okay, so I think it was scheduled for 2 hours, but I was able to complete in 1 hour only. So thank you for listening. I will start with a Q&A session if there is some Q&A. If you have some doubts, feel free to ask about the whole session, about anything else also you want to ask in the tech industry. I will be happy to ask.
Yes, sir. We will wait for 2 to 3 minutes for some questions.
Any courses on microservices? Oh, I have not got a list for now, but I will surely send to you through Brinzel ma'am. I will send you some free Udemy or some courses which you can get on microservices. General concept behind microservices is that microservice is more of a theoretical concept you need to understand. Coding wise, there will be no concept, because coding wise, it is the same code that you write for a monolith application, but just lot smaller. So coding wise, there will be not. Yeah. So good question. I think I didn't cover this question. So let me have that. Yeah. So as you know that nothing is perfect in the world. So microservices have its own disadvantages and problems. So I will discuss with you this problem. Just I have that written. Yeah. So microservices as so what the issues that we face with microservices are that microservices are very small, and we need to know how they are interacting with other microservices. So sometimes the testing becomes very much complicated than a monolith where everything is in one place. I need to do 10 things to achieve a thing that is there, the monolith, in microservices, because there is interaction between 10 different microservices. So the testing becomes complex. The second issue that is there, as everything, the communication happens over the internet, there is something known as latency. Like for example, for my voice to reach you, the internet is processing zeros, ones, and bytes. This same happens with microservice. They are not in the same code. They are not in the same file directory. They might be in two different servers, one in India, one in America. And the communication happens through an internet connection between the data centers. So there is some latency. So if your code can run a single computation in in a millisecond, it will take 10 milliseconds for the same code to run there and return back to you. So there is a concept of latency. So that's why it boils down to the previous point, that you should know that what should be in a microservice and what should be in a monolithic architecture. If there are a lot of heavy computations and you need it very quick, it makes sense to keep it inside your own microservice other than spinning out a new microservice which does that computation, because the computations are going to take a minute, and again there will be a lot of time that is be wasted for just communicating between the two microservices. So latency is one of the biggest issues. Again, one more issue is that microservices, there is no fixed way of designing a microservice. There is no a book written by it. It's all guidelines that you need to follow. So it might happen that microservices become too granular. Like there are so many microservices that you get confused at which microservices is doing what, because there is no defined job for it. So these are some basic disadvantages of microservice architecture. That the testing is little complex in terms for the setting it up, because you require a lot of data to be set up before you can actually test in other microservices as well. There is a lot of latency issues. So you should know that when you need to have your code in your own service and then spinning up a new microservice, and there comes up another issue that if I don't pay right attention to the design, I can have too many microservices which now I'm managing, where I don't require this microservices. These are very, very basic disadvantages of microservices. Good question. Anything else?
Yes, students, anyone is having any doubt, any questions that you want to ask Tanmay, you can still post it in the chat. The ones who are managing the YouTube stream, if any participant is having doubts over there, then you can post the question or read out the question over here in the meet. Tushar?
Yes.
Okay. So, any more questions or anything you want to ask Tanmay from the participants, you can ask, or we can come to the conclusion of this session.
Mm. Questions also can be unrelated to microservice, just in terms of tech. If you want to ask, that is also fine.
Yes, if industrial related or any other not related to microservices, some other platform or technology you want to ask for the current company scenario, or even about the company that he is working for currently, okay, about his this thing, that also you can ask it right now.
Yeah, sure.
Yeah, or he has provided his contact details. If you're not comfortable asking here, you can always contact him on the details that he has provided. So I guess no one is replying over here, meaning we don't have any more questions for Tanmay. So should we conclude this session? Tanmay, you have.
Yeah, ma'am. No.
I request participants to not leave. We want to have a group session at the end. But before that, I would request our student Parth to conclude this session by giving the vote of thanks. Parth, over to you.
Thank you. Good morning, everyone. All things come to end, so is the seminar. On behalf of ITSA, I take this opportunity to propose a vote of thanks to all those who have directly and indirectly contributed to this webinar on microservices. At the outset, I thank our chief guest and a resource person, Mr. Tanmay Colaco. We are enlightened with your knowledge and presence. Our heartfelt thanks to our students for active participation. Thank you.
So you have been a great audience.
Okay, I request all the participants of this meet to please on their cameras so we can have a group photo. Tushar, on your end, you can take the screenshot.
Yes.
Tushar, are you ready?
Yes.
And in the meantime, please post the attendance link as well. Students, you have to give the feedback, which will be considered as the attendance, which will help us in giving roll out the certificates to you. So now you can on the camera, please. Okay, Tushar, give us an indication when you are done.
Yes, I'm done. Ma'am, the link is also posted in the chat box.
Okay, I see that link. Tushar, just take the screenshot and tell us when you are done.
Yes, ma'am, done.
Okay, fine. Thank you.